Hi everyone, we're going to sketch a graph of this polynomial f of x, and first thing let's find the degree. So since this is not in standard form, what we're going to do is just look at the multiplicities here. They're all 1 and just add them up. 1 plus 1 plus 1 is 3. So our degree is 3, and that means it's an odd number, and we're going to look at end behavior in just a minute. And our lead coefficient here is negative. So we're going to be looking at odd and negative on the lead coefficient. Now my zeros, my y-intercept is when x is 0. So when you plug in 0 here, you get negative 0 times negative 2 times 4. That just equals 0. And for my x-intercepts, my zeros, you're going to let y be 0. So that's going to give you a 0 here. 2 minus 2 is 0, and negative 4 plus 4 is 0. And they all have multiplicity of 1, so that's going to be 0, 0, 0, comma 2, and 0, comma negative 4. Our maximum turning points, you use your n equals 3, so that's going to be 3 minus 1 equals 2. And our intervals where y is negative and y is positive, we're going to look at that after we graph it. So let's look at our end behavior. Remember, our n is an odd number, and our lead coefficient is negative. So we have odd and negative right here. In our case, our degree was 5. No, what was it? It was 3. So it just looks like that. And something like this. All right. And that just means, and we're just going to be looking at our ends. So there's your end here. Here's your end here. That means when you graph from left to right, we're starting in quadrant 2, where x is negative, y is positive. And we're going to be ending in quadrant 4, where your x is positive, but your y is negative. And that's what this means. X is positive, y is negative, x is negative, y is positive. So let's look at that. As x gets larger and larger from 0, our y gets negative, smaller and smaller. That means we're in quadrant 4. However, when x from 0 gets smaller and smaller, our y actually from 0 gets larger and larger. All right, so there's your end behavior. We'll be starting in quadrant 2 and ending in quadrant 4. So let's graph it. Let's put in our zeros and our y-intercept. So we have a 0 here, 2, and negative 4. We're not going to worry about our min and max values. If you want to graph this more accurately, you could actually plug in some more values and do that. We're just trying to sketch the normal graph. So all these, the multiplicity is 1. So that means it can cross the graph, now cross the x-axis. So as we hit, we're starting, remember, in quadrant 2. We're going to be ending somewhere in quadrant 4. So we're going to go to negative 4. Let's go negative 4. Now, since it's multiplicity of 1, we can cross. Now, we're going to 0, so we're just going to make some U-turn. Again, if you want to plug in negative 2 and get the exact value, you can. But we're just sketching the graph. So you go to 0. Since this is multiplicity 1, we can cross. And again, if you plug in 1, you'll get your maximum there. Go back down and go down here. So we can cross it too, again, because it's a multiplicity of 1. So there's your graph. Now what we want to look at is where y is positive and negative. So basically, where y, or f of x, is negative, it's below our y equals 0 line. So it's right here. This is where our graph is below the y equals 0, these two places. So that's going from -4 to 0, and from 2 to infinity. These are your x values. You're looking at your x-axis. Now, where is our y positive? Where is it above the y equals 0? And this is going to be this piece. And that's going to be from negative infinity to -4. And also right here, it's above the y equals 0 line, which is 0 to 2. And that's it. Thank you. Have a nice day. Bye-bye.